Majong buntag. Majong buntag. Atong topic karon is review of sequences and series. Mao ni ang topic para sa pre-calculus grade 11 STEM. So, mao ni ang situation na akong ihatag ninyo. Ang kani, klaro ba? Athea's classroom is on the second floor of the school. She can take 1 or 2 steps of the stairs in one leap. In how many ways can Althea climb the stairs if it has 16 steps? Kasi karon, ang stairs na 16 ka steps. So, pila kuno ka paagi, di ba? There are many ways sa pagtikang sa ladder or sa stairs. Pwede tag 5, pwede tag usahon ni mong lakang, o nagdali, pwede tag 8, ang kaduharang tikang, pwede po diretso 16 ka steps ang bakon. Okay. So I have here, para makahibaw ta og pila ka steps atong ganiron sa primero. Okay, for example, there is only one step in a stair. So notice that naray usa ka paagi. Kay usa ra man ka ang usa ra man ka step, te usa ra jud ka way, usa ra ka tikang. So kung duha ka steps, meaning pwede duhaon ni jud or tag 1-1, usa-usa, no? So manang two ways to climb the stairs kung naay duha ka steps. Kung naay tulo ka steps, naay kunoy 4 ka ways, tulo ka ones unja pwede katuloon nga tikang, then tulo ka tikang, then usahon ang usa, or tulo ka steps ka usahon, then usa, then usa ka duha, then tag usa-usa, kay 4 man, then pwede pug usa, then usa ka duha, ug usa ka usa, then pwede pug katuloon dadyon. Mo nang upat. Ang 4 ka steps daghan na, 8 na, pwede upat kalakang, ang upat ka ang kausahon, then pwede pug tagduhaon, pwede pug usa ka tinagduha, then usa na pud ka tinagduha, pwede pug usa ka usa, then duhaon ang ikaduha, then usa-usa, then usa, then tulo, diba? Maupat na tanong itong 4 ka steps. So manang daghan nga mo guys imong ma-form para laman makuha ang number of steps pa maabot nimo, ma-achieve nimo ang imong purpose. So mo to sa 16 na anay daghang ways. Okay, so we have this review of the definition of a sequence. That a sequence is a function whose domain is the set of positive integers, with a set containing 1, 2, 3, and so on up to n. Or it is a list of numbers separated by commas. No? Unsa man pud ang series? A series represents the sum of the terms of a sequence. It is the sum of numbers separated by plus or minus sign. So to illustrate, kaning babaw man ni sequence, meaning 1, negative 1/2, 1/3, 1/4, whereas ang series kay sum man 1 minus 1/2 plus 1/3 minus 1/4 then get the sum, which is 7/12. So mo tong duha. The sequence with in term E sub n is usually denoted by E sub n. Kung mangita ka og ika in term, and the associated series is given by S, or S sub n equals A sub 1 plus A sub 2 plus A sub 3 up to plus A sub n. So I have here examples. Example number 1, determine the first 5 terms of the sequence 2 minus n. Remember, 2 minus n, and give the associated series. Diba ang atong function kay 2 minus n man? Meaning, if our n is 1, so 2 minus 1, which is 1. If n is 2, so 2 minus 2 is 0. Then A sub 3, when n is 3, 2 minus 3 is negative 1. Then A sub 4 is 2 minus 4 is negative 2. And A sub 5 is 2 minus 5 is negative 3. So therefore, the first 5 terms are 1, 0, negative 1, negative 2, and negative 3. To get the series, simply add 1 plus 0 plus negative 1 plus negative 2 plus negative 3, or that would be equal to negative 5. So the sum of the first 5 terms is negative 5. Okay, determine the first 5 terms of the sequence 1 plus 2n plus 3n squared, and give the associated series. So 1 plus 2n plus 3n squared. So to get our first term, we have is 1. 1 plus 2 times 1 plus 3 times 1 squared equals 6. Then when n is 2, we have to replace the n with 2. So we have 1 plus 2 times 2 plus 3 times 2 squared equals 17. When n is 3, we have 1 plus 2 times 3 plus 3 times 3 squared is equal to 34. And A sub 4 is 1 plus 2 times 4 plus 3 times 4 squared equals 57. And the last one is 1 plus 2 times 5 plus 3 times 5 squared is 86. So therefore, the first 5 terms are 6, 17, 34, 57, 86. And the associated is the sum of those 5 terms, which is equal to 200. Example number 3. Determine the first 5 terms of the sequence negative 1 to the n power, and give the associated series. So negative 1 to the n. So when n is 1, we have negative 1 to the 1, which is negative 1. Then A sub 2 is negative 1 to the second power equals 1. A sub 3 is negative 1 to the third power is negative 1. A sub 4 is negative 1 squared is 1. Then negative 1 to the fifth is negative 1. Sorry, this is 4. This is negative 1 to the fourth is positive 1. So therefore, we have negative 1, positive 1, negative 1, positive 1, negative 1. Okay, sorry for this. This is negative. This is positive 4. And the associated series would be the sum of negative 1 plus 1 plus negative 1 plus 1, then negative 1 plus 1, and the sum is negative 1. Example number 4. Determine the first 5 terms of the sequence 1 plus 2 plus 3 plus up to n, and give the associated series. We have, for 1, the first one is 1, the first term is 1 plus 2, the third term is 1 plus 2 plus 3 plus 3 equals 6, and a sub 4 is 1 plus 2 plus 3 plus 4 equals 10, and a sub 5 is 1 plus 2 plus 3 plus 4 plus 5, which is 15. So therefore, our first 5 terms are 1, 3, 6, 10, and 15. And the sum of those 5 terms is equal to 35. So let's now proceed to the common sequences. We have the first one. The arithmetic sequence is a sequence in which each term after the first is obtained by adding constant called the difference to the succeeding term. So makuha nimo by adding the first ngadto sa second, the second ngadto sa first. No, second ngadto sa third, third ngadto sa fourth. Tawag atong i-add is we have the common difference. If the n term have an arithmetic sequence is a sub n and the common difference is b, then the n term can be done by adding a sub 1 plus the quantity n minus 1 times d. So example, what is the 10th term of the arithmetic sequence 5, 2, negative 1, and so on? 8, 5, 2, negative 1, and so on. So from this equation, we learned that our a sub 1 is 8. Then since we are asked for the 10 terms, we have a sub 10 and the n is 10 minus 1, and the difference, common difference is negative 3 because 5 minus 8 is negative 3, 2 minus 5 is negative 3, negative 1 minus 2 is negative 3. So in this case, we subtracted 10 minus 1, that is 9, times negative 3 is negative 27, plus 8 is negative 19. So therefore, the 10th term of the sequence 8, 5, 2, negative 1 is negative 19. The associated arithmetic series with n terms is given by, we have these two formulas. S sub n equals n over 2 times quantity a sub 1 plus a sub n if the n term is already known. But if you don't know yet the e sub n, we are going to use the second formula, which is n over 2 quantity 2a sub 1 plus quantity n minus 1 times d. Example, we have this. What is the sum of the first 20 terms of an arithmetic sequence 8, 5, 2, negative 1? Again, what is the sum of the first 20 terms of an arithmetic sequence 8, 5, 2, negative 1? So in this case, our n is 20, so here, and the a sub 1 is 8, our n is 20, and the d is still negative 3. So therefore, we are going to subtract 20 minus 1, it becomes 19. So we have here 19 times negative 3 is negative 57, plus 6 is negative 41, times 10 is negative 410. So in order to get the correct answer, we should master the formulas. So we can conclude that the sum of the first 20 terms of the sequence is negative 410. So if a sub n is an arithmetic sequence, then the sequence with n term is b to the n, or b sub n, which is equal to 1 over a sub n, is what we call as the harmonic sequence. So in this case, we can say that harmonic sequence are simply, or is simply, the reciprocal of the terms of the arithmetic sequence. Okay, reciprocal. So what is the next 5 terms of the harmonic sequence? 1/2, 1/4, 1/6, 1/8. So kay this is a harmonic man. What are we going to do is convert sa nimo to arithmetic sequence, meaning kuhaon sa nimo ang mga reciprocals. So therefore ang reciprocal ani, so 1/2 is 2, 1/4 is 6, 1/4 is 4, 1/6 is 6, 1/8 is 8. So unsa may next 5 terms after 8? We have 10, 12, 14, 16, and 18. So that's why we can say that the next 5 terms of our harmonic sequence are 1/10, 1/12, 1/14, 1/16, and 1/18. Okay, nakinumdum na. Next is we have the geometric sequence. What's the difference between geometric and arithmetic? For geometric sequence, it is a sequence in which each term after the first is obtained by multiplying the succeeding term by a constant. By multiplying. And katong gi-multiply is what we call as the common ratio. So notice that in the arithmetic sequence, we can get the second term by adding, or the next terms by adding a common difference. So in this geometric, we are going to multiply the term to find the next term, multiply it by the what we call as the common ratio. So for example, if we say, what is the next 3 terms of the geometric sequence 1, 3, 9, 27? So we are going to multiply 27 times 3 because 3 is the common ratio by getting 3 divided by 1, 9 divided by 3, 27 divided by 9. So therefore, kay 3 man atong common ratio, we need to multiply this 27 times 3 is 81, times 3 is 243, times 3 is 729. So that's why we can say that the next 3 terms of a geometric sequence are, we have 81, 243, and 729. How to get the nth term of the geometric sequence? So we have here a sub n equals a sub 1 times r to the power of n minus 1. Okay, again, a sub n equals a sub 1 times r to the power of n minus 1. So again, your a sub n is the nth term, your a sub 1 is the first term, your r is the common ratio, and the n here is the nth term. So for example, if we have this problem, what is the 12th term of the geometric sequence 1, 2, 4, and 8? What is the first term? We have 1. What is the common ratio? We have 2. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. So to get the 12th term, we have our a sub 1 is 1 and our ratio, common ratio is 2. So since our n is 12, so 12 minus 1 is 11. So therefore 2 to the 11th power is 2048 multiplied by 1. So therefore the 12th term of the sequence is 2048. So to find the associated geometric series with n terms is given by these two situations. That when r is 1, if the common ratio is 1, we simply multiply your n, the n term, the number of terms multiplied by the first term kung ang n nimo is 1 or no n. If your r, the common ratio is 1. So if it is not 1, we have to use the second formula. So a sub 1, quantity 1 minus r to the power of n over 1 minus r. Okay, so this formula will be used if r is not equal to 1. Okay, in this case, we're going to find the sum of the first 10 terms of the geometric sequence. -2, 6, -8, 54. So our first term here is -2, wherein our second term is 6. So if we are going to divide 6 divided by 2, our common difference is -3. We have -18 divided by 6, -3. 54 divided by -18 is also -3. So, to find S sub 10, or the sum of the first 10 terms, we substituted A sub 1 with -2, our R is -3, and our N is 10. So, then sa denominator, put 3. So, this becomes positive because minus the negative of 3. So, that's why -3 to the 10th power is 59,049. Then minusan 1, 1 minus 59,049, that would be -59,049 times -2. The answer is 118,096 divided by 4. That becomes 29,524. Okay, when R is between -1 and 1, the infinite geometric series would be A sub 1 plus A sub 1 times R plus A sub 1 R squared plus dot 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 plus A sub 1 times R to the n minus 1 plus has a sum and is given by S equals A sub 1 all over 1 minus R. This is for infinite geometric series, meaning infinite y kahumanan nga series sa geometric. We can find the sum. Okay, so in this case, find the sum of the infinite geometric series 1, 1/2, 1/4 plus 1/8 up to y kahumanan. So the solution would be, get the R. The R is 1/2 divided by 1 is 1/2. 1/4 divided by 1/2 is 1/2. 1/8 divided by 1/4 is also 1/2. So therefore, our A sub 1 is 1. Then 1 minus 1/2 is 1/2. So 1 over 1/2 is the same as 1 times 2 over 1, which is equal to positive 2. Then the next sequence is, we have this one, a common sequence, which is what we call as the Fibonacci sequence. So where its first two terms are either both 1 or 0 and 1. And each term thereafter is obtained by adding the two preceding terms. I know you know already what is Fibonacci. So what is the next 5 terms of in the Fibonacci sequence? 0, 1, 1, 2. So from the definition, that the Fibonacci sequence is done by simply adding 0 plus 1 is 1, 1 plus 1 is 2. So the next term would be 1 plus 2 is 3. Then 2 plus 3 is 5. Then 5 plus 8 is 13. And 8 plus 13 is 21. That is how we do Fibonacci sequence. So karon kamauna mo ma-identify o unsa nang series from sequence. Kamauna mo differentiate kung unsa nang arithmetic, geometric o Fibonacci. So I hope you learn from this video. So thank you so much for watching my video. I hope you will learn a lot. And if you liked it, please share to your friends. And don't forget to subscribe to my channel. So I am here inviting you to watch my other videos. If you want to learn more about pre-calculus. So, mao na to. ang inyong inahan sa mathematics, Leah P. Caragil, signing off. Bye-bye. God bless you always.